All right, so these are the answers and how you solve these problems 1 to 5. You definitely need to know the relationship between these three variables. Remember, frequency is nu, wavelength is lambda, and E is energy. So you should know that the higher the energy, the higher the frequency, the shorter the wavelength. In other words, energy and frequency are directly related, which means if one increases, the other one increases. And lambda is indirectly related to them, which means lambda wavelength does the opposite of frequency and energy. All right, let's look at this guy right here. So they're asking you to calculate the frequency, and they give you the wavelength. The only equation that we have that has frequency and wavelength in it together is C equals lambda nu. And then you have to manipulate the equation around to get frequency by itself. So frequency equals C over lambda. C is a constant. It's the speed of light, 3 times 10 to the 8th meters per second. And lambda, they were nice enough to give it to you in meters so you didn't have to convert it. If you want to look at the units, it's meters per second divided by meters, which is the same as saying meters per second times 1 over a meter. So your units are going to be 1 over a second. And when you work this out, make sure you use your EE button in your calculator, and you should get this answer. If you don't use your EE button, you will probably be off by 1/10. I will just put this in, double check my work. Okay. And if you get close to that answer, that's fine. Like when I just put it in, I got 5.53. So that's okay. This guy right here, they're asking you to find wavelength, and they give you frequency. So again, you have to go up here, look at the equations you're given that have wavelength and frequency in it together. Wavelength is C over nu. C is the speed of light constant. And nu is 6.99 times 10 to the 10th. And I'm going to change that hertz to 1 over a second. Because when I have meters per second divided by 1 over a second, it's the same as saying meters per second times second over 1. Your seconds are going to cancel, and you're just left with meters. So I'm going to double check my work. 3 exponent 8 divided by 6.99 EE10. And it does come out, ooh, no it doesn't. It comes out to a different answer. See, I'm glad I'm going over this ahead of time. It comes out to that. All right. Let's look at our next one here. So we have 4 and 5. I'm going to calculate the energy that ultraviolet has with a frequency. So you're looking for energy, and you're asked to find frequency. Write these symbols down. The only equation we have that has energy and frequency in it is E equals h nu. Remember h, we used it yesterday, as Planck's constant, 6.63 times 10 to the negative 34. If you want to use joules per hertz, you can, or you can use joules times seconds. If you use joules per hertz, then keep this as hertz. If you want to use joules times seconds, then you have to use 4.5 times 10 to the 16, 1 over a second. If I'm going too fast at any time, make sure you pause the video so you can get caught up. 6.63 EE negative 34 times 4.5 EE 16, and I get an answer of 2.98 times 10 to the negative 17th. My hertz cancels, and I'm left with joules. And this is another energy equation. E equals h nu, 6.63 times 10 to the negative 34 This time I'm going to do joules times seconds, so you know what I'm talking about. 4.34 times 10 to the 14th, and instead of using hertz, I'm just changing the hertz to 1 over a second. It's the same thing. We talked about that in the notes yesterday. Let's get an answer for this. 6.63 EE negative 34 times 4.34 exponent 14. And your answer comes out to be 2.88 times 10 to the negative 19th. And your seconds cancel, and you're left with just joules, which is an appropriate unit for energy. All right. Hope this helps you. Remember for tonight's homework, remember if you would rearrange this equation, nu equals c over lambda, and then you can put that into nu, and you have a new equation right there if you want to. Sometimes you're asked to find energy in given wavelength or vice versa. And remember, h is Planck's constant and c is the speed of light.